Welcome back. Let's go ahead and take a look at number 18. Write a two-column proof for the following, given that M is parallel to N and angle 16 is congruent to angle 6. So here, this is what you can assume, right? That's your given. So when you have these things, go ahead and start marking them down. So M is parallel to N, and 16 is congruent to angle 6, right? Angle 16 is congruent to angle 6, and this is all because of the given. Prove that J is parallel to K. So that means you're going to have to use one of those converse theorems, okay? So, this is pretty weird. This proof is going to... How I am going to plan this is... The explanation will be very, very difficult. Okay, I'm gonna admit that. So let me go ahead and just look at this picture. I know that 16 and angle 6 are congruent, and my goal here is to prove that J is parallel to K. Okay, and I can see that 6 is part of K, and 16 and 6, right? If I have parallel lines cut by a transversal, 16 is over here, and it's part of this transversal, but 6 is not part of this transversal, so this is going to be very, very interesting. I can't use that. I really, really, really can't use that, so I really think I need to make some sort of play, okay? So, let's say... Well, if I have this, right, and it's cut by this transversal, 16 is over here, 6 is over here. If I have these lines, 6 is over here, 16 is over there, but it's not sharing this transversal. Hopefully you know what I mean, because this is what I'm going to go ahead and do. My goal here is to show if the lines... are there, cut by this transversal. Here's 6, and there's 4. And notice that, because I can assume that these lines cut by a transversal, by the way, these lines are parallel, right? Again, I have parallel lines cut by a transversal, 16 and 4. Do you see that? 16 and 4, they're corresponding. Okay, so angle 16 is congruent to angle 4. They're corresponding angles. So I'm going to go ahead and just mark that picture down. So then let me go ahead and try this again. So I have these lines, they're not parallel, cut by this transversal, and these angles here are congruent. So now that these angles are congruent, they're outside, right? They're exterior angles, and they're outside of these lines. So angle 4 is congruent to angle 6 by alternate exterior, right? 16, 4, 4, 6. Oh, no. I should do this. Because 16 is congruent to angle 4. Yeah, let's take a look at this. So angle 6 is congruent to angle 16. So that means that, okay, angle 6 is congruent to angle 16, and angle 16 is congruent to angle 24. That means angle 6 is congruent to 4. I don't know why I said 24, but I meant to say 4. That's because of the transitive property. Okay, transitive property. Alrighty, let's go ahead and start with my proof. Because remember, with the converse theorems, it states that if you have if you have two lines cut by a transversal and the angles are congruent, depending on which it is, alternate exterior, corresponding, or alternate interior, you're basically using the converse theorems, right? So, like I said, this one's really, really difficult, and this is really, really difficult to understand. So let's just go ahead and just jump right into it. So, given M is parallel to N, and angle 16 is congruent to angle 6. And, okay, let me go ahead and rewrite this. So it looks like this. Angle 6 is congruent to angle 16. And by the way, that's a given. So angle 16 is congruent to angle 16. Angle 16 is congruent to angle 4. Therefore, angle 6 is congruent to angle 4. All right. Oh, by the way, what did I say? Angle 16 is congruent to angle 4. That's because of the corresponding, right? I just jumped right into the transitive stuff without writing the reason before that. So corresponding angles. And then again, that's angle 6 is congruent to angle 4. That's the transitive property. Therefore, that J is parallel to K by the, well, let me go ahead and take a look at this stuff again. So I have these lines, and then 4 is over here, 6 is over here. These angles are congruent, and they are outside of these lines over here. So that has to be alternate exterior angles, converse, okay? Because you're proving the lines parallel, you're using the alternate exterior angles, converse. My apologies if this didn't make any sense, but it was just basically trying to prove that these lines are parallel, right? And if you can see that those two angles are congruent, then use one of the use one of the converse theorems to prove that the lines are parallel. Let's go ahead and take a look at this one. Classified each triangle as acute, equiangular, obtuse, or right. So with acute, all angles must be less than 90 degrees. And with equiangular, all angles congruent, and usually they're just 60 degrees each. Obtuse means at least one angle that is greater than 90, okay? And then the right angle is basically you have one right angle. If you see a square or exactly 90 degrees, okay? So let's go ahead and take a look at 1920 and 21. And that was just basically a fast recap of everything involving, classifications, just by looking at their angles. So let's go ahead and take a look at 19. We got 58, 72, 50. 58 is definitely less than 90. 72 is definitely less than 90. And 50 is definitely less than 90. So that means this is an acute triangle. So this is an acute triangle. Number 20, 35, 120, and 25. Okay, so I have two acute angles over here, but definitely one angle that is greater than 90, right? Definitely one angle is greater than 90. So this has to be obtuse. And over here, you got 50, 65, 65. 65 is less than 90, 50 is less than 90, and 65 over here is less than 90, so that is acute. Okay, so this is an acute triangle. All right, now I got 19, 20, and 21 down. Let's go ahead and take a look at 22, 23, and 24. Classified each triangle as equilateral, isosceles, or scalene. So equilateral, all sides congruent, and the name lateral just means sides. Equal means like equal, so we have equal sides, all sides are congruent. Isosceles is essentially at least two congruent sides, and then scalene means scalene is just scalene. It means no sides congruent, so no sides congruent. So let's go ahead and take a look at ABD. So ABD, close it. Notice that I have 1, 2, 3 tick marks. They're all congruent. So this is an equilateral triangle. Okay, that's an equilateral triangle. Let's go ahead and take a look at BDE. So BDE, close it. And I can see that it has 2 tick marks. So 2 tick marks here, 2 tick marks here. That means that this side and this side are congruent, but they are not congruent to this side. So we have at least 2 congruent sides. And the one with at least 2 congruent sides, that fits the isosceles triangle criteria? Question mark? Yep. Isosceles. And then let's go ahead and take a look at the last one. We have EDC, close it. This side, there's 1 tick mark here, 2 tick marks here, and nothing there. So this has to be a scalene triangle, has to be. Okay? scaling. All right, I'll see you